Migrating an Oak project from RVC2 to RVC4 doesn't mean starting over. With our AI-assisted porting guide, you can make the migration process faster and easier. On RVC2, your application can run on both DepthAI v2 and v3. This guide assumes you're using DepthAI v2, so it first covers migrating to v3, then moving from RVC2 to RVC4. We'll start with only the RVC2 camera connected and keep the RVC4 camera disconnected for now. This guide assumes the RVC4 device has an internet connection. If you need offline deployment, check out our separate guide for fully offline setup. Let's run our existing project, which blurs faces in the video stream. The project at this point is running on DepthAI v2. We'll run it from a Python virtual environment with all the required dependencies installed. The DepthAI and RVC versions are displayed on screen, making it easy to see what is currently running. You can find the DepthAI porting guide in our documentation if you'd like to explore the migration in more detail. In this guide, we'll let AI agents handle most of the porting so we can focus on the key migration concepts. We'll follow the RVC porting guide linked below, which includes an optimized prompt for AI agents. The prompt points the agent to the guide and the Oak examples repository, where it can compare DepthAI v2 and v3 code. This approach works well for simpler projects, though larger ones may still require some manual changes. Here we've already opened the AI agent in the project root directory and pasted the prompt. We can also have it use the existing Python virtual environment and test its changes directly on the hardware, making the porting process faster and more reliable. The prompt in our porting guide will continue to evolve as we refine it for the best migration results. After a few debugging iterations, we're ready to exit the AI agent and run the project on the RVC2 camera using DepthAI v3. Now that the project runs on DepthAI v3, we're ready to move to RVC4. While DepthAI v3 supports both RVC2 and 4, there are still a few hardware-specific differences to handle in the code. You can find these in the porting guide, but because we included them in the prompt, the agent handles them automatically during the same migration process. At this point, we can disconnect the RVC2 and connect the RVC4 device. If you haven't set it up yet, follow the Oak 4 Getting Started guide for connection and setup. The project now runs on the RVC4 platform in peripheral mode. In this mode, most of the application runs on the camera, but it still requires a host computer. It's ideal for rapid prototyping or applications that don't need to run fully at the edge. RVC4 also introduces standalone mode, where the entire application runs directly on the camera. You can manage and control it through Luxonis Hub or over SSH. This mode is ideal for edge deployments where you want to eliminate the need for a host computer and simplify system wiring. The first step in adapting the application for standalone mode is redirecting its output to a web visualizer. We'll use an AI agent again to update the code, instructing it to use DepthAI's built-in web visualizer. Once the changes are complete, run the application again and open the provided link to view the stream. The application is still running in peripheral mode, but we're now accessing its output through the built-in web visualizer. To truly run the application in standalone mode, we first need to create an oakctl file in the project root. We'll copy the template from our documentation and use it as a starting point. You can find a link to the template docs page in the video description. This file defines how the application runs on the camera, including the base OS image, the required dependencies, and the entry point to launch when the app is deployed. The only change we'll make to the template is the application identifier and then save the file. We'll then use the oakctl command, introduced with RVC4, to deploy and manage applications on the device. We'll first use oakctl to list the available devices, then deploy and run the application on the only connected device. The application, OS image, and dependencies are then transferred to the camera. This step requires an internet connection and will fail if one isn't available. If you want to deploy apps without using the internet connection, take a look at our Oak 4 offline deployment guide, also linked in the description. The application is now running fully standalone on the device. Open the web visualizer to view its video stream. Next, we recommend learning how to deploy and manage the app on Luxonis Hub. Explore our documentation for more information.